Okay, first thing the first officer will do, get into the cockpit, open the oxygen access door. There's different oxygen access doors for access positions for different aeroplanes. Turning it clockwise, it'll open. Turning it anti-clockwise, will close the oxygen. Okay. Next thing the first officer will look, because it's easier to see a circuit breaker that's popped from the side than it is from the bottom. He or she will look over here and see what they'll usually see is okay, there might be a circuit breaker pulled on top here, which is a AHRS circuit breaker, which is the vibrator for the circuit breaker for the altimeter, if it's fitted with one. The two electric bay switches will be pulled more often than not, and the steering circuit breaker will be pulled. That's normal. So if you see that, don't worry. If you see anything else pulled, first get the maintenance guy to tell you why it's pulled so you can take it from there. Okay, so either the AHRS altimeter, this one, altimeter 2, this one is usually pulled, plus the two electric bay circuit breakers, plus the steering circuit breaker. That's normal. Okay, so we'll put the altimeter in. The electric bay ones we can still leave out. This will run the fans, which chows a lot of power, so we're saving some battery power. Next, first officer will look. You'll look this side. Look for a fire bottle, fire extinguisher. Then look on this side for a crash axe behind the seat here. Then we'll look for two sets of goggles. Here's one set of goggles. And then behind the first officer's side there's another set of goggles. Okay, then the first officer will get into his or her seat. Before they operate the seat, they'll open this door. This is the gear override free fall access panel. In front there is the electric override switch. It must be guarded. At the back here is the mechanical uplock release, and they must all be forward. Okay. On that side, that red lever, I'll just remove it there for me. This is called the Aerostess attitude adjustment lever. This is the happy side, this is the unhappy side. Okay, so you'll use the unhappy side and you'll put it, when need be, over the pin and you'll pull it. Okay, so you can put it back there for us, please. Okay, then the control lock is actuated, so in order to release the control lock, keep your left hand on the control lock's mechanism and you release it with your right hand and go forward. Okay, and that's where it will stay. If you want to set it, the ailerons must be full to the left. You raise the lever, pull it all the way back, keep it there, release it, now locked. Okay, so it's released. Right, then the first officer will then check the park brake is set. He or she will then come up to the overhead panel and start the power down switch check. The inverter number 2 must be on, inverter number 1 must be on. The battery is connected, so let's look. Battery gives you the power there. If we leave the battery connected and we leave the selector switch in this position, it's going to eat the battery. What's written on top goes to this side. What's written at the bottom goes to that side. So this is volts, amps, volts, amps. So if you put the selector in this position, it's going to show generator 1's load and volts on this dial, generator 2 loads and volts on that dial. Aux generator loads and volts in this dial, battery loads and volts in that dial. Central bus, this side, APU generator, that side. Okay, so now I check the voltage. We see it's 26 volts, that's good. Aux generators, off. electrical emergency switch, guarded to the normal position. Bus tie switches on. Power select switch off. Generator 1, generator 2 off. Alarm lights bright. Panel light off. Back signs, nav lights on. Internal lights in the cockpit stereo light we leave off for now because it's in the day. Emergency light switch off. Landing lights, taxi light, rotating beacon, strobe light, instrument with inspection lights and logo lights all off. Come to the panel this side. Okay, so we did this panel top to bottom. Then we're going to come across to this panel. APU master switch off. Fire extinguishing switch for the APU guarded open. APU generator off. APU bleed off. Number 1 front and rear electric pumps, fuel pumps off. Cross bleed closed. Number 2 front and rear electric pumps off. Electric feather switches guarded off. Prop sync, we don't work with overspeeds. With the props aux pumps, we'll work with it shortly and can do nothing there. Auto feather is in the off position. Tests are spring loaded to the off position, so that's where they'll stay. Prop sync is off. ECs, you get 2 types of ECs. You get one that just says off on, and this one is the modern one that says manual takeoff, climb, cruise. It must always be in takeoff, and that's where it stays. Don't change it at all. Ignitions themselves must be in the auto position. If they're in the off position like this, which happens when you do compressor washes, you'll try and start the engine, it won't start, the igniters won't come on. Everything will happen, but the igniters won't come on. In the on position, it's on, like normal on, continuously. Start position, it's in the spring loaded position. It's spring loaded to the normal position, so it's either on or abort. Okay, so we did top, bottom, top, bottom. Now we're going to go bottom, top, bottom. So we check the electric hydraulic switches for pump switches for green system and blue system are off. Anti-skids are on. Test for the brakes is just where it is. The ice light is where it is. Rudder, boost, green and blue system is both on. We can come down, make sure the electric hydraulic pumps are off, because if we switch the battery on with one of the electric hydraulic pumps on, okay, it's going to make a noise, but it's going to drain the battery really quickly and you can't start the APU then. Okay, we're going to come across up here to the ice and rain protection. Timer is off. The total temperature off. Test switch is guarded off, or at least is off because it's spring loaded to the bottom. All the other switches is off except for the propeller switch must be in the cold position. We always start in cold. When you do get up, get ice, and then we can go to the normal rather than starting in normal and then seeing, oh shit, we need to actually put it in cold. So we always start in cold. Pitot-static switches are off. Slip switch is off. Angular attack sensor is off. Windshield wipers are off. This is the old smoke detector system. This one's got an external one. It's a very scarce one. This that I've got in here. The windshield heats are seat test switch is spring loaded. Windshield heats are off. Temperature switches, they say usually start at 12 o'clock, but because it's hot here, we just put it to a straight there to a 3 o'clock position. You want to have the position of the switches in manual, because if it's an auto, it will control the valve, the cooling valve. But if you've got it in manual, you can physically control with this switch where the valve is going to. The valve will physically follow you. We always have this is for the cockpit, this is for the cabin. We always have the cabin temperature control switch in the manual position. We don't give it to the hostie because they bugger up the temperature. They put it too hot, too cold, too hot, too cold, too hot, too cold. It's in manual, so we physically control the valve. Okay, they forgot the switches on. The windshield heat, the windshield defog must be in the off position. Recirculation fans, both of them must be in the off position. The gasper fan off. Pack switches off position. This is the ram air switch. Problem switch. If the ram air switch is in the open position, you will have dual pack failures passing about 2,000 foot above ground, and you'll have smoke in the cabin and unpressurized flight. So we always want to make sure it is in a closed position. Left engine bleed, aka bleed number 1, bleed number 2, both are off or closed, and the cross bleed is closed. Then we come to the middle. Check the compass, correct the card, check it, it's okay. Check the compass, it looks like it's alright. This is the external ice light, or the ice detector. You press the button, it's going to test it, but not now. Come to the middle, make sure your T-handles are both pushed in. The bottles are hot wired to the the battery bus. So if I turn it, it's going to blow a bottle. So we don't want it, and it doesn't turn far. It only turns about that far, then it blows a bottle. Coming across to the right hand side, here's the fire test 1, fire test 2. This is for the baggage compartment. The extinguishing switch is guarded, so we can't press it. We go across, we make sure all the light switches are off. Come further across to the right there, there's a PAX oxygen switch down the bottom there. Make sure the PAX oxygen switch further to the right. That's it. Make sure the PAX oxygen switch is in the auto position. If it's in the off position, the passengers won't get oxygen. If it's in the manual position, you are manually dumping the masks. Then we come to the bottom there, that panel. Look at the furthest right switch, it says angular. It's got an angular linear setting. It must always be in angular. In angular, it will give you the angular difference between the degrees on the VOR. If it's in linear, it will give you the distance off the radial. So you'll have two different indications on your number 2 and number 1 side. We always want to have the co-pilot side and the captain side with exactly the same settings. The only one time that the settings will be different is during an ILS approach. When you're approaching the ILS, you'll use the VOR. If there is a VOR, you'll use the VOR on the pilot monitoring side to check how close we're getting to the radial or to the localizer inbound. And then once the needle starts moving on the VOR, then we'll call needle alive. Then we'll call half scale. At the half scale around about, the ILS needle should be coming in for the localizer, because then it should be full scale. Start to move. If we've captured the radial and we don't see ILS localizer at all, then we know there's a problem. Press the buttons, go around, go find out what's the problem. Okay, that's the only time that the settings will be different. Then we come across, make sure the gear's down. Over here's the backup battery, make sure it's off. Caged for the standby artificial horizon. Now all the radios and the comms should be on the radio master. It sometimes happens that COM 1 is on a separate bus. So whether you put radio masters on or off, COM 1 will stay on, so you must manually put it off. I don't know about this one, we'll see shortly. Okay, coming across, this is not the standard radar and GPS system that comes out in the plane. This one's got a different radar. It's an Avionics radar system. This is the global, this is a normal one, normal FMS. The TCAS, it's got TA only, so it's a TCAS 1. Here's a test function for it, it's down here. It's going to go TCAS system test, okay, and it's going to go through all the checks here on the vertical speed screen. This is a fuel totalizer. Elevator disconnect, make sure it's in. Well, not press there, but make sure it's in. Aileron disconnect on that side, make sure it's in. Everything normal down further here. Set the date. Today is the 19th of 9th. I think so, 19th. Right, if it's the 19th, we set it on the 19th. Okay, then we come across the trimmer. The trimmer can be in the green, which it is. The power levers have got a couple of positions. If you look down here, you will see as I move the power lever, these little pins move. That is called the sweet spot. That's beta. That's 0 angle. If you push them forward, you go towards flight idle. This is ground idle in that sweet spot. That's full reverse. So you want to have it in ground idle. There it says ground idle. That line must line up with the back of the levers. About there. Alright, go around buttons on the sides, that side and this side. Condition levers. Condition levers are now on fuel cutoff. If you press them forward, they is feathered and fueled. So that's where they'll operate. Minimum RPM. Notice that they click in for minimum RPM. That's to prevent you during normal RPM operations to put them into the feather position by accident. Okay, so when you want to put them in feather, you've got to physically pick them up, move them backwards. You want to cut it. Okay, if you want to cut it, you've got to pull it up, back, press the root tag, and then pull it into cut off. Okay, we've got to get used to this feeling of cutting it. You'll see some guys will try and cut it like this. It's an abnormal way to operate power levers like this. We don't do that, we use it like this. So we have to get used to bringing it, pressing the button, cutting it. Right, come across, trim agrees with what this trim on this side is saying. Flaps are up. Okay, nothing now to down, yeah. Okay, the flaps are up, normal. Packs oxygen in the auto position. Pressurization system in the auto position. The mechanical override for the pressurization system is in the pointing towards the green square here. That means it's in the parked position. If you want to operate it, use the QRH. Emergency / park brake. It's pulled. Now we don't know whether the accumulator is full or not, so we won't let it go now and pull it again. There's no power on the plane, so we've got no way to know whether there's actually enough pressure in the system for the park brake to operate. Coming across to the pressurization system, this is called the triple indicator. This is the normal indicator. This one has got the right knob over here. This right knob you can turn clockwise and anti-clockwise, and it's got a place where it clicks into position. Then it gives you 450 foot a minute rate of descent and 650 foot a minute rate of climb. This is the barrow knob, we never set it. This is just to set the barometric scale, but we never use it. This button over here tells you the altitude. Now how it works is the inside scale is the altitude of the aeroplane, and it will tell you what the on the outside scale what the pressure inside the aeroplane will be. So at 20,000 foot we'll have a pressure inside the aeroplane of 1,750 foot a minute, or at 1,750 foot. If we're at 25,000 foot, it will give us 4,500 foot. It can keep a cabin at 0 all the way to 17,000 foot and 8,000 foot cabin altitude at 32,000 foot aircraft altitude. Okay, this needle over here will then set to our altitude now, 4,150 foot. The triple indicator's got 3 indicators in it. This one on this side is the vertical speed indicator. This indicates the vertical speed of the cockpit and the cabin. So what the cabin is climbing and descending at the rate. That triangle P is the differential pressure. It goes all the way up to 7.2 to 7 psi normal, over pressure to 7.2, and then it will open the valves and just dump the pressure to keep the cabin pressure inside at 7.2 psi. That alt is what will indicate what the altitude inside the aeroplane is. So if I can close everything and I start pumping air in, pressurizing the cabin in other words, this altitude will go down, down, down until it gets to sea level. The trimmer, never reset the trimmer, the rudder trim. Always leave the rudder trim exactly where it is. It's the captain's problem, because this trimmer is via mechanical linkages connected to the hydraulic steering for the nose wheel. If you put this on 0, the airplane will taxi skew. It's just the way it was designed. So if you taxi it on anywhere between 1 and 4. Trim to the right. This one is 1.5, just over 1.5. Aileron trim, we'll set to 0 and we'll leave the aileron trim in 0. Stall warning switches, this is system 1, this is system 2. The switches are guarded and it's in the on position. It's an auto flight system, and the QRH, this is the quick reference handbook, the yellow pages. We'll use it a little bit later.